All right, so welcome everyone, and thanks for joining our session today. We are really excited to be here and have the opportunity to speak at the very first AWS Reinforce. My name is Daniel Koo. I'm a Senior Director at FINRA managing the DevOps products and engineering. On the stage, I also have Mele from FINRA, who's a lead developer, and Jason Garbis, who is the VP of product at Cyxtera. So in this session, we're going to talk about how FINRA achieves DevOps agility while securing our AWS environment. So quick agenda. So we're going to give an introduction about FINRA, and I'm going to talk about how FINRA performs secure development and how we practice DevOps. And then we're going to go into a tool that we developed called Gatekeeper and how it integrates with Cyxtera's AppGate SDP solution. They're going to show a demo, and then Jason's going to come up and give introduction to Cyxtera, and then do a deep dive into the AppGate solution. All right, so introduction about FINRA. So FINRA stands for Financial Industry Regulatory Authority. We are a financial regulator. We oversee the broker-dealer industry in the US. Our mission is to protect investors and promote market integrity. So in terms of our volume, we monitor 12 different markets and exchanges. We regulate more than 3,800 different broker-dealer firms and more than 634,000 brokers that are in securities in the US. FINRA is a big data company. Recently, we processed up to 135 billion transactions in a single day. That was our record that we reached very recently. So it shows how enormous amount of data that we ingest, that we process, and we analyze. When we reconstruct the market events that we receive, it can get up to trillions of edges and nodes. So that shows the complexity of the data that we deal with. We can use up to 50,000 compute nodes per day to process and analyze our data. And when we talk about our storage, we have close to 30 petabytes of data that we store in AWS. We have more than 150 different applications that we are running in AWS to perform our regulatory functions. Some of the challenges that we face while migrating over to the cloud. It's been about 4 or 5 years since our cloud migration journey started. And FINRA being a regulatory company, it is critical for us to think about compliance and security. All the audits that we have and all the things that we need to govern, it is very challenging for us to meet all these demands in terms of compliance and security. So we need to have proper frameworks in place, proper tools and processes in place for us to govern, right? To see if teams are following the standards and the policies that we have set. And transparency is very important. We need to make sure that we know and we understand what is happening within our environment. Access control, which is going to be the key topic of this session. It is important for us to tighten our access control. Make sure that we follow the least privilege model. We only give the access that are absolutely necessary. And also, cloud being a transient platform. You never know when the instances will go up and down. They're very short-lived. So the way we were thinking on-prem, the traditional data center, is different when we talk about cloud and when we think about solutions for the cloud. You need to be resilient, and you need to be thinking about these transient platforms. And lastly, DevOps. We want to make sure that we follow the DevOps methodologies. Automation all the way through, self-service, in order for us to be more agile and faster time to market. So we invest a lot of our efforts and time to make sure that we have proper DevOps practice put in place. Putting all this together, again, compliance and security is one of the most important aspects within our technology solutions that we bring forward. So I want to talk a little bit about our DevOps practice. What you see here are the 4 typical stages that teams go through. Right? The inception phase is when teams start thinking about either migrating over their app to the cloud from on-prem or starting up a new development project. Then we have the kickstart phase. This is where teams start thinking about creating their code base. And in this case, we're talking about both infrastructure code and application code. Then you go through your development testing cycle, and you get ready for production. And once it is in production, now that it's released and users are consuming, we need to continuously monitor and make sure your application is healthy. Okay? So I'm going to talk through some of the key tools within each of these stages. We have more tools that we use, but I want to highlight some of the key tools. So during the inception phase, we have these two tools that we developed in-house. The first tool is called Onboard. This is something that we developed 4 or 5 years ago when we started. This helps you to set up all of your access needs. It sets up things like your Active Directory group. It sets up your IAM roles, right? All the stuff that's needed for teams to get started to have access to AWS. It also sets up things like your Jira project, your wiki space, your source control repository, and everything that's needed for you to get started. We also have an app called Portis, which we developed together with our security teams, where a security team will define the policies, right? The white-listed rules that they want to see in the security groups. And then the development teams will create their security groups based on the policies that are set by our security teams. The next phase is Kickstart. The very first tool that you see is called Provision. This is a tool that we developed to help teams create resources in AWS. Right? It follows patterns. We have built-in types where, for example, if a team is creating a traditional 3-tier web applications, they're going to need a load balancer. They're going to need their auto-scaling group. They're going to need their database, RDS instance. So what this does is it creates these resources in a compliant, standard manner. We try to bake in all of the compliance items and the security in the tool itself so that when teams use this, the resources that are created are already compliant and they don't have to worry about compliance. Similarly, AppConfig is a Puppet Ansible module where teams use to install software and configure the software, the middleware platforms like Apache's, Nginx, and Tomcats. Again, we go through the same process of making sure all the compliance items and security is baked in to the module itself. So as soon as you use it, it's compliant out of the box. Jenkins is what we use for our CI/CD. We have built a solution called F3, which helps teams create their Jenkins jobs, their build and deploy jobs, and their pipeline in a standard manner, right, based on templates. So all the jobs and pipelines that we see also has all the compliance-related items in there for reporting purposes, for governance purposes. It's already baked in, and it's automated all the way through. Docker and AMIs, so Docker images and AMIs. So we follow a patching cycle model of teams consuming these images on a monthly basis and redeploying their applications. And when they do that, all of the images, the base images that we create are already patched. It has all the necessary security tools, monitoring tools, and logging tools all baked in. So when they build on top of our base images, again, all of the compliance is already in place. Now you go through your development testing cycle. You use the same tools that I just mentioned, and then there's a few more that we leverage within this stage. We have a tool called Fidelius, which helps you manage your secrets. So you can capture secrets, and you can retrieve secrets using API, CLI, using this tool. We also have a tool called CloudPass, which is used to obtain temporary STS token that expires within an hour that you can use to make API, CLI calls from your local desktop during your development and testing. Once it's ready, it gets released, it's in production. Now you need to do continuous monitoring. So we have tools like Splunk, AppDynamics for performance monitoring, Nagios for alerting. And we also have a tool called Gatekeeper, which we're going to talk about more in detail later. This helps you to gain temporary access to EC2 instances and RDS instances. And we have another tool called Affiliate, which we use to monitor AWS service usage. And then when it reaches a limit, it will alert you. So what are we trying to achieve using all of these tools, right? Standardization, compliance, baking in all the standards and compliance in the tool itself. Integrating security and ops from the beginning, not thinking at the back. end, but we're thinking from the front, following architecture pattern, and automation all the way through, self-service all the way through. This helps teams to be more agile and be faster. Many of the tools that I just mentioned are open source, so I encourage everyone to go check out our open source website. Some of them are already available, and we have many that are coming soon that you can leverage. All right, so I'm going to talk a little more about compliance, how we stay consistent and how we stay transparent. So here is the flow, a typical flow. We have our security team and our enterprise architecture working together to define our standards and policies. All right, once they're defined, that gets fed into a team that is developing the DevOps tools, the tools that I mentioned, right? Creating compliance stacks, creating compliant configuration, approved security groups, approved IAM roles. Those are all baked into the tool. So now, once the development team consumes these tools, again, when they deploy, it's already compliant. So they would deploy to their development account, and they use the same automation to deploy into higher environments. Now, once their application is deployed, we continuously monitor. We make sure there's no, the configuration changes and all the change events that are happening within the environment are captured. Right? We have compliance reports that we generate that captures what's happening within our environment. We are notified of instances that are not patched, right? Based on which AMI they're using, which image they're using, right? Any changes that are happening within the environment via code or other events, those are all captured in our compliance reports. And those reports are now used by our audits, our operations, our security. And then what we do is now we fine-tune the standards and policies. We add, we remove, we make changes, and then we go through the same cycle again. Some of the important aspects within cloud security that we try to follow. Isolation. It is important for us to have the right balanced isolation. VPC isolation, security groups, different accounts based on SDLC, microsegmentation within our apps. So we try to follow right balanced isolation. Encryption. You've heard throughout this conference, right? Encrypt everywhere, encrypt everything, and that's what we try to follow as well. We heavily leverage AWS KMS, and anything in transit and anything at rest, we try to encrypt. Authentication and authorization. This is also very important that everything, every component that we have, that we go through proper authentication and authorization. We use role-based access control, and we also use Active Directory groups for performing authorization. Monitoring, again, transparency, right? We need to know exactly what is happening within our environment. We use tools like CloudTrail, CloudWatch, Splunk to monitor everything that is happening within our environment. And lastly, access control. Again, it is very important for us to tighten our access control. And wherever possible, use temporary access instead of permanent access. We use IAM ADFS Federation, again, temporary STS token, and then the gatekeeper tool to grant temporary access to EC2s and RDS instances. And this is what I want to dive into next, is our tool that we developed called Gatekeeper and its integration with Cyxtera's AppGate. So quick overview of Gatekeeper. So Gatekeeper is a web-based application. So user would access the application through the browser. And then when they perform an action, it will call our backend microservices. And when that happens, it will go through proper authorization. It goes through our AD to find out your group membership and then determine your access privilege. And all the requests that you make are recorded within our RDS as far as our history. And then once you're approved, what it will do is it uses AWS Systems Manager, SSM, to actually interact with the underlying instance that you want to gain access to. It creates a temporary user and then sends the temporary key to the requester. And for our RDS instances, it makes direct database calls to the database to create a user, and upon expiration, it will remove the user. And this can be replicated across multiple VPCs across multiple accounts. All right, so before we talk about the integration, I want to give a quick primer on AppGate. So AppGate SDP, it provides the identity-centric network security. It has 3 different components: the controller, the gateway, and the client. The client is what's installed on each user's machines, and then it securely authenticates user to the controller. And then what it does is it sets up the network routes via the secure tunnels. So the controller is a centralized authentication point. It is the one that interacts with your existing IAM system, and it performs the authentication. It's a virtual appliance that can run anywhere. And lastly, the gateway, which is the inline virtual network appliance that sits in between your client and the underlying instance that you want to gain access to. It creates a secure connection. It acts as a firewall, enforces policies, and it helps you to simplify your AWS security groups. All right, so now I'm going to hand it over to Steve, who's going to come up and talk about how we integrated Gatekeeper and AppGate.
Thank you, Daniel. So before we get started with the demo, I'm going to give a quick overview of what the current state of Gatekeeper and AppGate looks like in our environment. So first off, the users have the AppGate clients installed on their Macs or PCs. And first what they will do is they will log into the box. So to log into AppGate, they use their network credentials. And then once that's authenticated, they will have a secure connection to the AppGate gateway. So now one thing that's different right now, or one thing that is right now, is that AppGate has policies set to open up to the entire VPC. Now what the user needs to do is the user has to go to Gatekeeper and request access to the box that they want to get on. So once they request access to this box, it goes through a whole approval process, and once the request is approved, Gatekeeper will generate a temporary user and a private public PEM key file and send the private key to the user. Once the user has that private key, they can then log into the instance on the VPC. So now what I'm going to do is go over the demo of the current system. Also with this demo is an overview of the Gatekeeper app. All right, so this is the Gatekeeper landing page. So for this purpose, we're going to get requests to an EC2 instance. So firstly, we're going to select myself, and then I'm going to go ahead and find the instance on our dev account that we're going to use for this demo. We're going to select US East, Linux, and then we're just going to go ahead and search for our resource by name. So I'm going to enter the prefix to what our instance is named on our environment, and then I'm going to click search. So there's 2 instances that come back. So for the purpose of this demo, I'm going to select the first one. Now on the bottom, you can see the summary of the request. I'm going to request for 1 hour. And as you can see, the request requires approval because I do not have the proper permissions to get access to this box. So what I'm doing now is I'm entering my justification. So the justification is just that this is the reinforced demo. And I'm going to provide an incident number to help the ops team track what this is for. Once I am completed with that, I'm going to go ahead and submit this. And the system's going to confirm that the access request was created. And then I can go and preview it right here. So the next piece now that we're stepping into is the approval. So now I'm going to be in the approver role, and the approver will be able to view all the currently active requests that need to be reviewed. And as you see here, the approver has access to all the information about the request, who the users are, what instances, what their justification is, what ticket ID, and then they can also provide comments on whether they're approved. So now the request is approved. So what happens is Gatekeeper will generate the user and create a public-private key pair. That's what you see here. So what I'm going to do now is I'm going to grab this key pair and I'm going to log into the box that I requested for. So first I'm going to set it up so that it's read-only, and then I'm going to go ahead and SSH into the box. So as you can see here, the network is hanging because I'm not logged into AppGate. So now what I'm going to do is I'm going to go ahead and log into the AppGate client with my network credentials. And then I'm going to submit it. So now it's authenticating. Now I'm on the AppGate. So now I'm going to go ahead and cancel that connection and try again. So as you see now, when I tried to connect again, now I need another token. So our network requires multi-factor authentication. So I'm going to provide my RSA token to go through. And now I'm logged into AppGate. Now you'll see shortly here, it'll let me through into the instance. And now I have access to the box. So now, 1 hour later, the request expires. Gatekeeper will kick out another notification saying that, hey, your access is up for this box. Now, if I try to go and log back into that box again, you're going to see that I do not have access to the box anymore. So as you can see here, I was still able to get onto the box, but my user's gone, so I can't get onto the box directly. Now, with AppGate, this is the state that we are actively working towards. The state is pretty much the same for the user. They're going to still log into their AppGate client, and they're going to connect to the AppGate gateway. And then they're going to connect to Gatekeeper and request access to the instance. All the same way as before, except once the request gets approved, there is one big difference here. So while Gatekeeper will still create the temporary users and PEM key pairs, it's also going to pass along this request data to the AppGate API. And the way we achieve this is through pushing out the request details to an SNS topic, which then has an SQSQ that our AppGate team uses with a Lambda. That Lambda will take that data and call the AppGate API to register all the IPs of the associated instances to that request to be able to have the AppGate policy allow. Once that's done, the user has their key and then they can log in. And now, instead of having the entire VPC in the AppGate policy, they only have the resources that they have access to. Now I'm going to show a demo of this new state. So the first thing we're going to do is we're going to try to connect to the box that we're going to request to. But first, as you can see, our AppGate entitlements are empty. Now I'm going to try to connect to this box through an SSH call. So as you see, I don't have any network access to this box. So now what I'm going to do is I'm going to go to Gatekeeper and I'm going to request access to get on this box. So I sped this up because I showed this in the last demo. So I'll fill out the access request like before. And then I have my request open, so it gets approved. And now when I look at my key now in the inbox, so you'll see I have access. First things I want to show is the IP in the AppGate policy. So if you look here, when I look at my entitlements, you're going to see I have a Gatekeeper entitlement for the box on port 22. Now I'm going to go ahead and try to SSH back into that same box. So as you see, I'm able to get onto the box now. Now, what happens when the request expires? So for the user end, it's the same thing just like before. They're going to get a notification saying that, hey, your access is up. Now let's check the AppGate entitlement and see what actually happened. So we're going to go back to the AppGate window, and we're going to look at the entitlements. As you see, that gatekeeper policy is gone. So what happens when I try to connect now? I'm blocked. I can't connect through the network anymore. So not only are we removing the user forcefully from the box, we're also taking away the user's network access. So goals achieved here. We have self-service. So if there's an issue and a user needs to get on an instance, they can go to Gatekeeper and request it for whatever they need. The grant and removal of these users and access to the network through AppGate is completely automated. We're leveraging existing group membership to determine how tight or how loose approval criteria should be for Gatekeeper. And we have no hard users on our instances, only temporary access. This is big because a lot of instances before this came with a lot of users to be able to log in just before. But now with Gatekeeper, we don't need those users anymore, and they're completely transient. They get created and they get cleaned up automatically. And finally, we have multiple layers of protection, from auth-n to auth-z, for Gatekeeper and AppGate, and the approval process of Gatekeeper. We can make sure that users actually need to get on those resources as necessary. And to back that up, we also have security groups and AppGate software-defined perimeter on our back protecting the network. And finally, we have full auditability and transparency. As Daniel alluded to in the Gatekeeper architecture, we store all of this request data onto an RDS instance. So it allows us a full traceability of who got access to what, when they got it, and why they needed it. What I'm going to do now is I'm going to hand over to Jason. He's going to introduce Cyxtera and their AppGate solution. Thank you.
Great. Thank you, Steve. Thank you, Daniel. This has been a great partnership, and I want to thank you for being a customer for so many years. And it's been great to be together on this journey as you folks and your teams have moved from a traditional on-premises environment and have gone full bore into AWS and are doing a lot of really interesting things there. And we've learned a lot from you as a security provider and as a vendor to you. And I want to share some of that with the rest of you here today. So just a brief overview of Cyxtera, the company. So we are a vendor. We are a security provider. We have a number of products under the portfolio that we call Cyxtera Essential Defense. This portfolio is built on three principles around helping organizations reduce their attack surface, secure access for users and services, and neutralize adversaries. And there's a number of components to it. We have a multi-factor authentication solution. We have a set of digital threat protection products and services to help organizations fight phishing attempts and perform mitigations and takedowns. Then we have a set of both offensive and defensive threat management and analytic services. The core of what we're talking about today, however, is the AppGate SDP product, and that provides this software-defined perimeter and microsegmentation capability, and that's what we're gonna dive into. We're gonna take a step back and talk a little bit about some of the challenges that we face as an industry and ways to overcome them with a newer architecture. And first, the bad news is that number one, the fundamentals of our network infrastructure, TCPIP, was not designed with security in mind. It provides a very weak foundation for us as security teams because it's built on this notion of implicit trust. And we know this, but sometimes it's hard to kind of remember that it doesn't have to be this way. TCPIP is built on this notion of connecting first and authenticating second. What it means is that anyone who's on the network or any attacker, potential attacker on the internet for our publicly exposed services can see our servers. They can see what ports are open, they can interrogate them, and they can generally connect to them, establishing a TCP connection, chewing up resources on the server, and then and only then is there some sort of authentication, application level authentication that happens. And a good example of that is, of course, SSH and having the SSH keys. But fundamentally, we believe that this is completely backwards. We shouldn't be exposing these services to malicious users or users with malware or potential attackers on the internet because there are far too many vulnerabilities in our software stacks, and the ability to send a packet to a server, the ability to establish a network connection to a server, we believe is in fact a privilege that needs to be managed and controlled just like any other privilege on the network. The second challenge around TCPIP is that because it's built around IP addresses, it presents us with a very impoverished language with which to express security policies. We all know that what we're configuring in our traditional firewall rules and even in our security groups in AWS is essentially a question like this. Well, should this source IP address over here get access to this target IP address and port over here? And that's not a very interesting question. And it also forces us to answer it in a way that is kind of all or nothing, black or white, yes or no. And as we all know, these rules, our firewall rules or our security group rules, tend to get set and they tend to never change. And we believe that this is, again, the wrong way to be thinking about access control and security. Now, the good news is that there's a newer architecture that's out there that we believe is a far superior way of approaching this. And this is not something that Cyxtera as a vendor invented. This is an open architecture called the Software-Defined Perimeter. It was created by the Cloud Security Alliance, which is a nonprofit industry consortium. And anyone and everyone is welcome to join and contribute to this. This architecture, while it's new, is really built on some very well-proven principles and security techniques that we'll talk about. The Software-Defined Perimeter Architecture, or SDP, has three main components to it. The first is this notion of making it identity-centric. We need to move away from using IP addresses as identities because they're just identifiers and they're shared, of course, by lots of different people and they change all the time. We need a security model that's built around the identity of the user or the identity of the server and pulls together different pieces, different facets of context around the user and their device and around our security ecosystem to enable a much more expressive policy language around what this identity should or shouldn't get access to at this given point in time. Second is that it's built on this notion of zero trust. While zero trust is a buzzword, we also believe that there's a lot of depth to it and it's actually a very valuable destination or journey that organizations should be on. And the idea around zero trust is let's enforce the principle of least privilege from beginning to end, from the network level all the way up to the application level. And we believe, the SDP architecture believes, that no user should be able to connect to a resource until and unless they've been properly authenticated and validated and that there's a level of trust that's been established there. We also believe that the network should essentially be dynamically provisioned for the user based on this type of context. And we saw a great example in the demo and the examples that Steve gave for FINRA. And then finally, the SDP architecture is fundamentally designed to meet today's complicated and dynamic cloud environments where, like in FINRA's case, resources are created and destroyed on demand very, very rapidly, and the security solution needs to keep up with that. So if we think about what SDP does as an architecture, is it really compensates for some of the weaknesses and challenges of TCPIP, and it really turns this on its this process on its head, and it enforces a mechanism of authenticating and authorizing first before a network connection is allowed to be established. And this all of a sudden changes things. It allows us to much more confidently have these services running without fear that an unknown or perhaps known and unpatched vulnerability in maybe an SSH server or a VPN server was going to be exploited. And the way it does this is it forces authentication through a mechanism that I'll talk about in a few minutes. Then and only then, after this basic authentication occurs, can a network connection actually be established. And then, of course, applies additional levels of security, including identity verification and authorization. And then finally, SDP exposes only those very specific resources that this given user is authorized to see at this given time on the network. So we're really enforcing the principle of least privilege. What this allows us to do, the way we implemented this in our product called AppGate SDP, now lets us ask much more interesting questions in a much richer policy language. So now we can look at this and say, the question we want to ask is, should this user Jim have access to our SAP production server? That's all of a sudden a much more interesting question because it's not an IP address that might be transient or might be shared by 100 users because things get natted. We're talking about Jim, and Jim is someone that we know a lot about. He's probably an employee, he has a certain role in the company, he works in a certain office, etc. Likewise, the resource that Jim is trying to access has attributes. This is a production server, so there's probably some additional security controls that we want to enforce versus, say, a development or a test server. And the answer to this question is actually interesting as well, because it depends. We shouldn't give Jim carte blanche or 24/7 access necessarily from any device, from any location on the planet. Really what we want to do is, we want to have a policy model that lets us ask some additional questions, some additional context around when and under what conditions Jim should actually get access. And that's exactly what the AppGate SDP product implementing the SDP architecture provides, is the ability to express in a way that's meaningful and dynamic these types of policies that can restrict access based on time of day, device posture, security context, or even connections to additional business systems, such as, is there a service desk ticket that's in an open state that indicates there's a problem on a server and that someone from our IT team needs to log in and address. So that's a little bit of the context, and now we're going to go to the next level of detail on the AppGate SDP architecture and how it works. So Steve already introduced the three main concepts of the AppGate client that runs on the user device, the controller that acts as a centralized authentication point and policy store, and the gateways that run inline. What I'm illustrating here is, first of all, as a distributed system, these gateways can and should be placed as close as possible to the resources that they're protecting. And in this diagram, you can see we've got gateways running in, let's say, 2 different regions across AWS, protecting multiple VPCs. These gateways can also be protecting different accounts, so that it's a nice way of providing a unified security model across what might be a complex AWS infrastructure. The principle of least privilege applies not only to those protected servers running in the VPC, which users can't get access to until they go through the authentication steps, but actually to the components of the AppGate SDP system itself. So the controller and the gateways utilize a mechanism called single packet authorization to ensure that they're invisible on the network to unauthorized users. These systems don't respond to port scans, they don't respond to attempts to open up TCP connections, so that from an unauthorized user, for a malicious user on the internet, there won't be any attack surface for them to do any reconnaissance here or attempt to connect. If and only if the user has a properly onboarded device, which includes a shared secret, will that device then be able to generate a hash message authentication code that's embedded in the first network packet that's sent to the controller and the gateway. That single packet authorization, or SPA, then allows the controller to open up that port for that particular client and then allow a mutually validated TLS connection to occur. So controllers and gateways are invisible, only authorized users, only authorized devices can connect, and then there's additional levels of validation where both sides, the client and the server, are validating the certificate for mutual TLS. Then the user's credentials are sent, either because they type them in or because they're cached, and the controller validates that against the organization's identity management system. This allows the organization to get more value and benefit from the work they've done for user onboarding, group membership, attributes, and things like that. Those pieces of information, identity attributes, device context, user context, are then applied to a set of policies that are defined, and the AppGate system then determines what set of network resources this given user should get access to at this point in time. That information is then put into a token and sent down to the client device, which then goes through the same step to establish this mutual TLS connection to the set of appropriate network gateways that sit in front of the resources. And then after that process happens, which takes maybe a couple of seconds, the user will then have network routes to get access to the right set of resources that sit behind the gateways. What's nice about the AppGate system is that those policies, the policy language that we've created, is very dynamic, and it gives organizations the ability to look at not just fixed things like IP addresses, but to look at dynamic things such as tags or security groups, or even other custom mechanisms for resolving or distinguishing these servers. The effect of this is it lets organizations who are using AWS simplify their security groups and effectively just have one rule for the components, the EC2 instances in their VPC, and the one rule is accept all traffic from the gateway. And by the result of that is that they will not accept any other traffic. So we've enforced the principle of least privilege for those, and have delegated essentially the policy enforcement mechanism to the AppGate gateway, which utilizes the model that we just talked about. So let's dive into this and see this in action. And should switch. Okay. So on this device, I'm logged into AppGate. You can see the client here, and we'll dive into that in a minute. One of the entitlements that I've gotten, as I've already gone through the authentication process and gotten my network entitlements, is the ability to access a simple web server that's running in AWS here. So if I click on that, that should pull up in a second. And now it's simply displaying a very simple diagnostic page that's running on this Linux server, and it's running in the EUS2 in London. Pretty simple. If I look at the set of network entitlements here that this user has, we can see that this one here, AWS demo static IP address, and I'm going to zoom in on that for readability. This is a pretty simple policy. It essentially says, for those sets of resources running in AWS London, I've been given the network entitlement, the capability to connect up to that fixed IP address, that 10.205 address, from using TCP and ICMP on a given set of ports. And the up direction means that it's a connection that's initiated from my device up to the server. And our system supports down connections, although I won't be demonstrating them today. And the conditions attribute of this is always, which is there's no additional checks that will apply. And we'll see a couple of examples of how we might use that a little bit later. So this is really not that interesting, right? It's very useful, better than a VPN because the system itself is protected, but it's not very dynamic. So let's look at another policy here, and it's this one here called AWS demo usage tag. So I'm going to zoom in again. So this is the gateway that's protecting resources in the Northern Virginia region. And what's interesting about the actions on here is you can see there's no host names or IP addresses defined, but it's actually using the syntax that we've created to dynamically resolve AWS tags. So in this case, it's using the name is usage and the value is AWS demo, and giving me the capability to send ICMP packets or establish a TCP connection. Again, the condition is always. So let's take a look at this in action here. So I'm logged into my console here in Northern Virginia, and I happen to have two instances that I've filtered out. This one here is at the private IP of 10.201.4.176, and you can see there is no public IP because this is only accessible through the gateway. In this case, my tag usage has the value AWS demo. So according to the policy, I should be able to access this particular server. If I look at this one here at 10.201.4.6, my usage tag is set to AWS test, which that does not match the policy. So I shouldn't be able to get access to this. Now let's verify that. So if I try to ping the 176 one, you can see that's successful. And the reason it's successful, if I go back here, is because this tag is set up to match what the AppGate SDP Cloud Resolver expects. Great. So now let's take a look at the one that'll fail. So I'm attempting to ping 4.6, and that's failing because the tag doesn't work. So let's go ahead and change that. Now obviously, I've logged into the AWS console here, and I'm doing this manually for the purposes of demo. In real-world environments, this tag would generally be changed by a script, by some sort of DevOps toolchain, or, in fact, a system might create a brand new EC2 instance that has a tag set a certain way, and then the system would recognize it in the same way as me changing the tag here. So I'm going to change that to AWS demo. And within a few seconds, the ping should now succeed. Here we go. So the Cloud Resolver has detected the tag change and now allows my access into this resource. So I love this demo. I think it's really interesting because it shows the usage of an AWS mechanism tags in a way that can be automated and scripted. And you can see that my user access has now changed, and I get access to this thing in a way that is completely transparent. I don't have to sign out and sign back into anything. I don't have to refresh anything. I'm just doing my job. And this is very similar to the 2B state in the Gatekeeper application, where they're not using tags, they're using a slightly different mechanism, but both ways work equally well. All right. Then finally, we talked a little bit about conditions. And the conditions, the gateways, have a mechanism to dynamically enforce essentially real-time conditions for when user accesses certain resources. This is often used to do things like interrogate an outside system like a service desk to ensure there's a ticket that's in an open state before a user can access a given resource. It's also very, very commonly used to enforce multi-factor authentication or step-up authentication under certain circumstances. So you can easily imagine a policy, for example, that says, well, if you're on the office network, you can simply connect with basic authentication to the service. But if you're remote, we're going to ask you for a second factor. That's a very common policy that the customers put in place. So in this case, I've got this AWS demo FIDO2 MFA condition. And if you look at that, it's simply allowing me to send ICMP commands, ping traffic, up to this given server at 10.200.2.109. And the condition is that it's enforcing FIDO2. And it's going to require me to insert this FIDO2 key and touch it before I can get access to it. So let's give that a try. Oops. So you can see my ping is failing, and that AppGate has popped up a little prompt to the user that says, hey, you got to take action here. So I will insert that. Give it a second to recognize it. It gets accepted, and now you can see that my ping traffic is coming through. So that's a great example of a dynamic type of step-up authentication that can be enforced when users are accessing any mechanism, any types of resource whatsoever. Great. Okay. So what we've done here is we've introduced this open architecture called the software-defined perimeter. And as I mentioned, this is not something that we as a vendor created. It's been created by the Cloud Security Alliance. One of my roles, in addition to working for Cyxtera, is I'm a co-chair of the software-defined perimeter working group at the CSA. And we'd love to have more folks involved to help us advance the state of the art in this, continue to research and publish around use cases and how this type of architecture can be applied to cloud environments. This information is all freely available on the Cloud Security Alliance site. Just look for the Software-Defined Perimeter Working Group. We have a number of documents, including the core specification. We have a research note that specifically dives into how SDP can be applied to infrastructure as a service environments. And we have a new reference architecture guide that we published around SDP. I hope that what we've illustrated through FINRA scenarios and through the demo is the ability to have this kind of transparent and concurrent access across different AWS accounts in different regions, with the ability to very dynamically adjust what users get access to based on context and based on metadata. There's additional scenarios that we'd be happy to talk about, whether it's applying multi-factor authentication or integrating with additional elements of your security infrastructure, such as your SIM or a service desk, as I mentioned. We are here exhibiting down in booth 228. We'd be happy to talk to you and meet with you. And the product is also available in the AWS Marketplace with a free trial if you want to do that way. And we have what's called a test drive that's available through our website. So with that, I think I'm going to wrap up. Again, I want to thank Daniel and Steve, thank all of you, and we'll be available for questions after this if you want to learn more about the product, to learn more about FINRA and some of the benefits they've gotten from utilizing AWS in this way. Thank you.